Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College. In the lecture series of Fundamentals of Mechanical Engineering, which is the first year course, today I am covering a topic related to unit number 5, related to temperature measurement. So, the particular topic in temperature measurement, I am basically going to cover the topic optical pyrometer, which is the very frequently asked question in university examination. But before moving towards the optical pyrometer, I would like to start my lecture with some basics which we are already knowing. So, what is basically the temperature measurement and what is the fundamentals? So, temperature, I don't think whatever written over here on the slide is new to anyone, but still, what is the temperature? So, that is what known to us. It is a relative term which measures the degree of hotness or coldness. This is known. From the 9th class onwards, we are studying this particular definition. So, temperature. And this relative term, which is the measure of hotness or coldness, decides what? Decides the direction of heat flow. As we all know that the heat flow, the heat transfer is always taking place from high temperature body to low temperature body. So, the body which is at high temperature, from that the heat is getting transferred to the low temperature body. So, this is what the basics about the temperature. I am not going in the much detail of the temperature, but this much we must know before the start of the topic. Then our interest is not the temperature only, our interest is the temperature measurement. So, what is the basic funda? How do we measure the temperature? So, the very fundamental thing is written over here, that is the equality of the temperature or the state of thermal equilibrium. Suppose this is the thermometer I am carrying here. If I have to measure the body temperature or the ambient temperature, then I will keep this thermometer in the contact with the surrounding, or for the body temperature, I will keep this thermometer in the contact with my body. So, if my body is at higher temperature, then the heat transfer takes place from the body to this thermometer. Up to what time? Up to the time of the state of thermal equilibrium. It means the equality of temperature. When both the bodies are at the same temperature, then transfer of heat is not there. So, that is what the basic concept when we are going to measure the temperature. And measurement of temperature is known as, basically we all know the equipment, the tool which we are using, that is the thermometer, and the science behind it. That science includes the selection of the property, which property we are going to utilize for the purpose of temperature measurement, which scale we are going to use. If I am talking about the scale, it means the temperature scale. We all must be knowing different temperature scales. We are having the Celsius scale, we are having Fahrenheit scale, Kelvin scale. I am not going in the detail of this because all these are fundamentals which are known to us. But if I talk about the thermometry, then thermometry involves all these things. Which property, which is the basic concept behind the temperature measurement, in which scale we are going to measure the temperature, how the calibration will be done. So, all these are the part of the thermometry. So, now moving towards the temperature measurement. So, what are the different ways? What are the different concepts through which we can measure the temperature? We must know. We are not only focusing on the optical pyrometer here only. At least we must know what are the basic concepts. So, the very first and most common, that is the liquid thermometer, which we are using in our home for measuring the body temperature, for measuring the ambient temperature, that's the liquid thermometer. And in liquid thermometer, what is the liquid? The liquid is mercury. that mercury is having a tendency to expand with the temperature rise. So that thermometer we are using, that is the contact type thermometer where the expansion of mercury is taking place. So very simple funda, very simple concept. In the bulb of the thermometer, the mercury is filled. As soon as it receives heat, it expands, and by the capillary action, it rises in the thermometer. So through that, we measure the temperature that is known to us. Okay. Second one, that can be a gas thermometer. Gases are also having the property to expand with the temperature change. We all know the ideal gas equation, PV equals to RT. So if volume is constant, R itself is a constant, then pressure of a gas in a container is directly proportional to temperature. So by that way, we can measure the temperature. I am not going in the detail of these. Okay. So at the last, I will be focusing on the optical pyrometer, but at least we must know the basics. What are the different ways through which we can measure the temperature? Another way of measuring the temperature, that is the pressure measurement. So pressure measurement, we are having the transducer like Borden tube. So if I can measure the pressure, then by calibrating the temperature and pressure, as it is already shown here, P is directly proportional to temperature. So if I am able to measure the pressure with the help of Borden tube, then definitely I will be able to measure the temperature also. Another property which changes with the temperature, that is the resistance of a metallic wire. Resistance also changes. Yes, resistance changes with the length. Resistance of any metallic wire changes with the cross section, and resistance also changes. Resistance of any wire, any metallic conductor changes with the temperature, with this particular relation. So that can be helpful. That can be helpful for measuring the temperature. Different type of thermometers are used for the different accuracy, for different precision, for different purposes. That's why we are discussing different properties. What are the different properties which can be utilized? So resistance changes with the temperature. So how much the resistance is changing? That can be studied through the Wheatstone bridge. In 12th class electrical topics, that students study about the Wheatstone bridge, how the Wheatstone bridge is balanced, galvanometer reading is 0. If the temperature is changing, then one of the resistance is changing. Because of that, the balance of that Wheatstone bridge becomes unbalanced. So by again changing the current, we can balance that Wheatstone bridge. So that property is helpful for measuring the temperature. Another property which can be utilized for the purpose of measuring the temperature, that is the expansion in the metal. Suppose these are the two metals. Okay, these are rigidly fixed with each other, but their coefficient of expansion with temperature is different. So as soon as the temperature is changing, what will happen to that? One will try to expand more, another metal will try to expand less. This will cause the bending. So that bending of bimetallic strip can be useful for measuring the temperature. So these are the different, I have focused on what are the different properties which we can use for the purpose of measuring the temperature. Now I am coming to the main point, the question which is coming in the exam, that is the optical pyrometer. What is pyrometer and for what purpose it is used? It is used for measuring very high temperature where contact type thermometers are not suitable. Contact type, if the temperature is very high, if I am going to utilize the liquid thermometer, the simple thermometer, then definitely there are chances that that thermometer will get damaged. So for that purpose, we have to use which type of thermometer? We have to use the non-contact type thermometer. So which basically the pyrometer. And now I am coming to the point Q. What is the basic concept behind the pyrometer? So the concept behind the pyrometer is very simple, very simple. It works on the disappearing filament principle. Disappearing filament principle. We know as the temperature of any element or any filament is changing, it generates heat, and along with that, it also illuminates some amount of light. And the light intensity of the object depends on what? It is the function of temperature. So how much light is getting illuminated, emitted from any hot surface, that is the function of temperature. So it means if the temperature is very high, then the illumination will be more. If the temperature is low, illumination will be less. So that property is utilized for that purpose. So again, I am coming to the point. It works on what? It works on the disappearing filament principle. Okay. And the surface for which the temperature is to be measured, the temperature depends, the intensity of light emitted from that surface depends on the temperature. So in order to measure the temperature, the brightness generated by the radiation of the unknown source or hot body whose temperature is to be determined is compared with some reference. And that reference is what? That reference is filament. So if two surfaces which are at same temperature will emit same intensity light, that is the basic principle behind this. Okay. For that purpose, the brightness of the reference lamp adjusted so that its intensity is equal to the brightness of the hot body which is under consideration. So the brightness from the reference lamp through which the filament is connected and the brightness of the intensity of light emitted from that surface are equal. So that is the basic funda behind the disappearing filament principle. That is the, okay. Now, how will we change the intensity of light of reference lamp? With the help of battery and rheostat. Battery is connected there, through which a rheostat is connected there. I will be discussing with the diagram also. So from that rheostat, if I am changing the resistance, then obviously the amount of current will change. If the amount of current is changing, then obviously the temperature of that wire will change. So temperature of that filament change, so the brightness of the light. So that is the basic concept behind the optical pyrometer. And now, what is the constructional detail of optical pyrometer? So all the constructional detail are written over here, but I will prefer to cover it with the diagram. So here I am coming to the diagram of optical pyrometer. Okay, this arrangement, complete arrangement is known as the optical pyrometer. This is the surface, hot surface for which the temperature has to be determined. Okay, so obviously if the temperature of the surface is very high, it will emit some amount of light, its brightness will be fixed and it depends on the temperature. Okay, so for observing it, the observer is here, we are observing from here, there is an arrangement of eyepiece, there is an arrangement of absorption filter, there is an arrangement of red filter, there is an arrangement of lamp. So I have to compare the brightness of light of filament and hot source. Okay, so what is the purpose? From the battery, the current is drawn. If I am changing the resistance with the help of the rheostat, then obviously the current passing through this lamp will be different. I can vary the current. With the help of this rheostat. So if the current is changing, then obviously the light emitted through the filament will also change. And if the brightness of these two sources, one is the reference, that is the filament, another is the hot surface for which the temperature is to be determined. If the brightness are equal, then this filament will disappear. That filament will be disappeared. ऐसा लगेगा कि जैसे ये दिख नहीं रहा है. Okay. So for that purpose, for better observation, we have an arrangement of eyepiece. So that by adjusting the eyepiece, we can focus the hot surface as well as filament. The red filter is there because this hot source and this filament are emitting a band of wavelengths. So by using the red filter, that can be converted into a monochromatic wavelength. Now the purpose of absorption filter. The purpose of absorption filter is simple. So whatever the light is getting emitted, so most of the light which is not essential is absorbed here, so that the intensity of lens can be, intensity of the filament can be optimized, so its life will be more. So the principle is simple. It is emitting some light of some intensity and brightness, and I am varying the brightness of the light which is getting illuminated through the filament by changing the rheostat resistance. So by this way, there can be three conditions. What three conditions are there? When a current passing through the filament is very low. If the current through the filament is low, as compared to what? As compared to the light which is getting emitted from here. So if the current is low, then obviously the illumination of the filament will be low. In that condition, what will happen? In that condition, we will be observing dark filament. We will be observing dark filament because the brightness of the light from the hot surface is more as compared to the brightness of the light illuminated from the filament. So this is what written over here. When the current passing through the filament is low, the radiation emitted by the filament of a lesser intensity than that of the source, and the filament appears dark. So this is the diagram number 1. In the second case, when the current passing through the filament is exact, and how we are varying the current? We are varying the current with the help of rheostat by changing the resistance. So if the current is exact, then the intensity of radiation from the filament as well as from the hot surface will be equal. So in that condition, the filament disappears. That current is useful. That current is related with the temperature. That can be calibrated with the temperature of that hot surface. Third condition क्या हो सकती है? The third condition, when the current passing through the filament is high as compared to the previous current. So what will happen? That will be bright. Filament will be brighter as compared to the hot source. So that is the third condition. So when the current passing through the filament is very high, the radiation emitted by the filament is of higher intensity than that of the source, and the filament appears brighter. So these three conditions. This is when current through the filament is more. This is when the current through the filament is less, and when the current through the filament is exact. Exact means when the filament disappears. It means the light emitted by the filament and the hot surface is of the same brightness. So the filament disappeared. That current is of our use, and that current can be calibrated with the temperature. So this is what the working of optical pyrometer. The details related to the basic principle, it is written over here. Why we are using pyrometer? So if you are answering the question related to the optical pyrometer, our first aim to justify why optical pyrometer. Then in the second stage, you must write what is the basic principle behind the optical pyrometer functioning. Then the constructional details and a neat and clean diagram if you are drawing in the exam and showing how these three things are happening. So this completes the discussion related to optical pyrometer. Thank you very much for watching the lecture. Thank you.